For any help regarding computer network assignment, help. Visit https://computernetworkassignmenthelp.com/https://computernetworkassignmenthelp.com. Email support@computernetworkassignmenthelp.com, support@computernetworkassignmenthelp.com, or call us at +1 678 648 4277. Problem 1. True or false? Circle T or F for each of the following statements to indicate whether the statement is true or false and briefly explain why. A. TF with all equal-sized intervals. A greedy algorithm based on the earliest start time will always select the maximum number of compatible intervals. Solution: true. The algorithm is equivalent to the earliest finish time algorithm. B. TF the problem of weighted interval scheduling can be solved in O, n log n, time using dynamic programming. Solution: true. The algorithm was covered in recitation. C. TF if we divide an array into groups of 3, find the median of each group, recursively find the median of those medians, partition, and recurse, then we can obtain a linear time median finding algorithm. Solution: false. T n equals T n/3 plus T 2n/3 plus O n does not solve to T n equals O n. The array has to be broken up into groups of at least 5 to obtain a linear time algorithm. D. TF if we used the obvious theta n2 merge algorithm in the divide and conquer convex hull algorithm, the overall time complexity would be theta n2 log n. computernetworkassignmenthelp.com. Solution: false. The time complexity would satisfy the recurrence T n equals 2T n/2 plus theta n2, which solves to theta n2 by the master theorem. E. TF Van Emde-Boas sort, where we insert all numbers, find the min, and then repeatedly call successor, can be used to sort n equals LGU numbers in O, LGU, LG, LG, LGU, time. Solution: false. Inserting into the tree and then finding all the successors will take n LG, LG, U, time, which in terms of U is LG, U, LG, LG, U. F. TF Van Emde-Boas on n integers between 0 and U-1 supports successor queries in O, LG, LGU, worst case time using O, n, space. Solution: false. We use theta, U, space or do randomization. G. TF in the potential method for amortized analysis, the potential energy should never go negative. Solution: true. H. TF the quicksort algorithm that uses linear time median finding to run in worst case O, n log n, time requires theta, n, auxiliary space. Solution: false. It can be implemented with O, log n, auxiliary space. I. TF searching in a skip list takes theta, log n, time with high probability, but could take omega, 2n, time with non-zero probability. computernetworkassignmenthelp.com. Solution: true. A skip list could be of any height with non-zero probability, depending on its random choices. Alternative solution: false. We can limit the height of the skip list to O, n, or O, LGN to get O, n, worst case cost. Common mistake 1. We go through each element at least once. Wrong because we also need to climb up the skip lists. Common mistake 2. The worst case is when none of the elements is promoted, or all of the elements are promoted to the same level, in which cases skip lists become a linked list. J, T, F. The following collection H equals H1, H2, H3 of hash functions is universal, where each hash function maps the universe U equals A, B, C, D of keys into the range 0, 1, 2 according to the following table. Solution, false. A and C collide with probability 2/3. Computer Network Assignment Help.com. Problem 2. Fast Fourier Transform, FFT. One part, Ben Bitdiddle is trying to multiply two polynomials using the FFT. In his trivial example, Ben sets A equals 0, 1, and B equals 0, 1, both representing 0 plus x, and calculates. So C represents 1 plus 0x, which is clearly wrong. Point out Ben's mistake in one sentence, no calculation needed. Ben swears he has calculated FFT f and inverse FFT f minus 1 correctly. Solution: the resulting polynomial is of degree 2, so Ben need to pad A and B with zeros. Or Ben need at least 3 samples to do FFT. Here is the correct calculaton, not required in the solution. Let A equals B equals 0, 1, 0, 0, then. Computer Network Assignment Help.com. Which represents x2. It is also okay to set A equals B equals 0, 1, 0. Common mistake 1, A asterisk operator B should be convolution. Common mistake 2, Ben should reverse B. Both mistakes confuse the relation between convolution, polynomial multiplication, and FFT calculation. If one computes convolution directly, without FFT, one needs to reverse the second vector. FFT provides a faster way to compute convolution and polynomial multiplication. These two are the same thing. Using the FFT, one should perform FFT on the two original vectors, no reversal. Then, after the FFT, one only needs to do element-wise multiplication, as opposed to convolution, which Ben performed correctly. Problem 3. Yellow brick road. One part. Professor Gale is developing a new Facebook app called Yellow Brick Road for maintaining a user's timeline, here represented as a time-ordered list E0, E1, N-1 of N, unchanging, events. In Facebook, events can never be deleted, and for the purposes of this problem, don't worry about insertions either. The app allows the user to mark an event EI as yellow, important, or gray, unimportant. Initially, all events are gray. The app also allows the user to jump to the next yellow event that comes after the event EI currently on the screen, which may be yellow or gray. More formally, you must support the following operations. Computer Network Assignment Help.com. 1. Mark yellow. I mark EI yellow. 2. Mark gray. I mark EI gray. 3. Next yellow. I find the smallest j greater than I such that EJ is yellow. Give the fastest data structure you can for this problem, measured according to worst case time. The faster your data structure, the better. Hint: use a data structure you have seen in either 6.006 or 6.046 as a building block. Solution: initialization takes O, NLG, LGN, time to insert all the yellow elements into a VEB tree, V. More importantly, each operation takes O, LGN, time. When a user asks to mark yellow, I, then call v.insert, I, which takes O, LGN, time. When a user asks to mark gray, I, then call v.delete, I, which takes O, LGN, time. When a user asks to next yellow,